Now there can be some cases where an explicit conversion is also required. For example, if you consider this example, here we have a floating point number z, and then we have two integer variables x equal to 10 and y is equal to 3. Now we need to perform x by y and store that value of x by y in z, right? So this expression, this set of expressions will give 10 by 3, which is equal to 3, because both these values are integers. So the resultant of 10 by 3 is also an integer. So this is the value of 10 by 3, and then this value will be stored in float, right? Z equal to 3. Since this is an integer and then this is floating point number, compiler will implicitly convert this integer to floating point number by having 3.0. So finally Z will have 3.0 in its memory. In fact, it stores 3.0000006 zeros, right? After decimal point, it will have 6 digits for a floating point number, right? So this is how it stores the value of z. But the actual value of 10 by 3 is 3.3, right? For example, 10 by 3 should give me 3.33. In fact, it has these 6 threes after decimal value. So this value should be stored in z. That is what should happen. But since these two values x and y are integers, it has yielded only the integer value, and the integer value is stored in floating point number. So an implicit conversion during assignment happens, and 3.0 is stored instead of 3.33, right? So to get this value in z, what you should do is you should explicitly specify to the compiler that it has to consider one of these variables as a float. For example, you can just tell the compiler to consider x as float and then divide the floating point number with an integer value, right? Since one of these values is float and the other is integer, the compiler does an implicit conversion and then converts this also into float, then carries out this division operation, right? So what it does is, after specifying to the compiler to consider x as float, it will take 10.0 then 3, right? So here 10.0 is float and 3 is an integer. So by the implicit conversion, it converts this also into float, 10 by 10.0, 3.0, right? So 10.0 by 3.0 will give me 3.333333, right? This will be stored in Z. So to store the correct values of the expression, sometimes you may need to have an explicit conversion. So as a programmer, you have to specify to the compiler to consider x as float and then carry out the evaluation of this expression. So since you are explicitly telling the compiler, this is called an explicit conversion. And now let's look at the syntax of explicit conversion. This is called a typecast operator. This is called typecast. This means you are casting the type of operand into another type. So this is called casting operator or typecast operator. Now let's look at the syntax of this cast operator. So the explicit conversion is done with the help of cast operator. Now the syntax is, you will just specify the data type within the brackets and then followed by the expression. The expression can be a constant or a variable. For example, in the previous slide we have seen float x by y, right? Here float is the data type which we want to assign to this operand, and then followed by the expression. Here the expression is this one, right? This is the variable here, and then followed by the rest of the expression. So you are just typecasting the variable x here. You can also have something like this: float x by y. This means you are performing the division operation first, and then whatever value it yields, you are typecasting the value to float, right? So this is the syntax for cast operator. And now note that the cast operator which is applied on a variable is only temporary until the evaluation of this expression. So after the evaluation of this expression, the variable x will take its original data type. The cast operator works only for the temporary purpose, only during the evaluation of the expression, right? After the evaluation of expression, the variable x will take its original data type, which is int. So if you are going to use the variable x later down the line, it will be an integer only. Now let's look at an example to understand this explicit typecast operator. So here is an example to understand the use of typecast operator. So here we have x and y, which are x is 10 and y is initialized with 3. Both of these are integer variables, and then we have floating point numbers which are p and q, right? Now in this expression we have p is equal to x by y, right? So x by y, x is 10, y is 3, so 10 by 3, which will yield 3, because both of these variables are integers and I don't have any typecast operator here, right? So the value of 10 by 3 is 3, and you are storing 3, which is an integer, into a floating point number, right? So this, you are doing this, right? P is equal to 3. So here this is a integer and this is floating point number, and this is your LHS and this is your RHS, right? So what compiler does is, while assigning, the type of RHS will be converted to the type of LHS, right? So this will be stored as 3.00000060, yeah, so 3.060 zeros in P. So it will have 3.00, so P will have 3.000. Whereas in this expression we have Q equal to float x by y, right? So what you are here you are explicitly telling to the compiler to convert the type of x to float and then perform this division operation, right? What happens here is 10.0, then 3, right? After converting x to float, I will have 10.0s, and then there is division operator followed by 3. So this will give me 3.333333, right? So you are storing, so in this case you are storing Q as you are storing this value in Q. So Q will have 3.333333. 3. So in these two examples, in these two expressions, you can observe that in case of P, we are losing the actual value, right? The actual value of 10 by 3 is 3.333, whereas you are just storing 3 in P. So sometimes you may need to have explicit conversion like this. So let's quickly run this program once to see what the output of P and Q are. So if you observe, P has 3.00, whereas Q has 3.333, right? This can be achieved using the explicit conversion, right? So this is how the explicit conversion works. Let's look at some more examples for explicit conversion. So here we can have a typecast operator for constant, where this is a floating point number and you are asking the compiler to convert this into integer, right? So what it does is it just drops off whatever values, whatever digits we have after decimal, and then it gives you the integer value of this floating point number. This we have seen in the previous program, where we are converting the first operand 10 into float and then applying division operator, right? This will give you 3.333 and so on. In this case, we are doing division operation first, which will give me, so let me write here, we have float and 10 by 3. So this operation is performed first, and then so this will give me 3, and then we are applying float typecast operation to this, right? This will give you 3.0 because you are converting the integer into floating point number. So finally this will yield 3.000, and in this case, this is an expression, double will be applied to the first operand x, and x will be converted to double, and then this expression is evaluated, right? But in this case, the expression is evaluated first, that means x plus y plus z is evaluated first, and then whatever value we got here, that will be converted to double, right? So these are some of the examples for using typecast operator.